Probably the most fundamental concept in probability theory is that of an experiment. By an experiment, we typically mean some sort of action that we carry out to check the validity of some hypothesis. The picture shows an experiment dealing with induction. In probability theory, the word experiment is used slightly differently. By an experiment in probability theory, we typically mean any sort of action followed by some sort of observation. The standard example in probability theory of an experiment is that of tossing a coin. So the action is to toss a coin and then we observe if it lands heads or tails. For a process involving an action and some observation to qualify as an experiment in probability theory, there is an additional requirement. The requirement is that the observation or the outcome must be one of the possible outcomes that we defined before the action. For example, before flipping a coin, I can identify all possible outcome of this experiment, and those are simply heads or tails. To give you an example of what would not be considered an experiment in probability theory, let's say that the action is that you drop your iPhone and the observation is that you observe the pieces. This is not an experiment because you have not identified all possible outcome. To make it into an experiment, you could say instead that I drop my iPhone and then I observe how many pieces it falls into. That way, the possible outcomes are 1 if it's intact, or 2, 3, 4, 5, and so on. So we can define in probability theory an experiment simply as any process or action which will result in precisely one out of a pre-identified set of possible outcomes. So before the experiment is performed, the possible outcomes must be identified. Here they are illustrated by squares. Each square represents a possible outcome, so in this case there are 16 possible outcomes. The experiment will then lead to one of these possible outcomes being singled out, for example, this one. But of course we don't know that before the experiment. It's common to denote the set of all possible outcomes using the symbol S. This set is then called the sample space of the experiment. To write down the sample space, you write S equal to, and then you put all the possible outcomes inside curly brackets. So for example, if my experiment is to flip a coin, I can put head, comma, tail. And that's my sample space for this experiment. Here's the most common experiment in probability theory, that is tossing a dice. The action is of course the actual toss, and we define the set of possible outcomes to be 1 through 6, which is the sample space for this experiment. Once we've tossed the dice, we can observe the number on the upper surface of the dice, and that will be the actual outcome of the experiment.